Yeah, hi everyone. So welcome to the session. So we were studying about Cartesian coordinate system. So now we need to define the differential length. So in differential length, what we do? In all the direction we work small length. So in rho we will work small length, in phi we will work small length, and in z we will work small length. So this is your rho, and what is your rho direction? This is your arrow. This is your arrow direction. So in arrow direction, if I work small length, d rho. So simply I am working d rho length in arrow direction. There is no doubt about that. I need to work small length in arrow direction. Small length in arrow direction. So what will be the vector representation? D rho length I am working in arrow direction. So d rho arrow cap. And one more thing I forgot to tell. Whenever I am working in a particular direction, rest all coordinate will be constant. That phi and z will be constant. That means this angle will be constant. Now you cannot say that, sir, now I will work in rho direction but at some other phi. Nah, phi is constant, and also the z coordinate is also constant. Z coordinate in the air, that will also be constant. So basically what you are actually doing is that this is your rho, and in the air there will be z. The z is coming towards you, and from this point you are working a small length in rho direction. Here you are working a small length in rho direction. So z did not change. This z is the same only. Here I have shown that you are working rho here, but actually you are working this rho. Are you getting this point? These two are parallel to each other. Here you are working d rho. Actually this is your phi, this is a certain rho, and this is a z. This point is there. Now with respect to this point you are working small length d rho in arrow direction. This is your arrow direction. So this will be your arrow direction. Are you getting this point? Let me make the coordinate system. So these two coordinates I am making, and this is the third coordinate. Okay. So your point was somewhere here. Now what is the direction of rho? Let's just say this is the direction of rho. So in this direction you are working small length. This was your point. In the direction of rho you are working small length. So the same length can be projected here. So this is what I am showing here. Actually there is rho, phi and z fixed, and here you are working some small length d rho, and you get to the new point. Here z is the same coordinate. Whatever z, let's just say z was 4 here. So here also z is 4. Z did not change. In the air I am going from the same point to same point. This is your z coordinate, no? This is your z coordinate. Here I worked from here to here to here. So z coordinate did not change. Rho coordinate changed. Only rho coordinate changed. Even phi coordinate did not change. Phi coordinate was also constant. So rho and phi are kept constant. So actually you are working in the air, but that will be tough to visualize. So that's why I am showing it in your xy plane only. I hope you are understanding it. Now you are working small length in a phi direction. Which will be your a phi direction? This is your phi, and this is the angle that is taken in anti-clockwise direction. So what will be your a phi? This will be my a phi. This will be my a phi, right? A phi. Now I need to work a small length in phi direction. Now let me know what will happen. So if I am working a small length in phi direction, that means my angle will be changed from phi to phi plus delta phi. Say yes or no? My angle will be changed from phi to delta phi. Rho will be same. This rho is same only. If this length is rho, same length I am working. Just the phi has changed to phi plus delta phi. So this angle is delta phi. This much angle is delta phi. So this was rho. Z coordinate is also same. So there I am just working some direction in phi. So I was here, then from here to here I worked. This I am showing with a very small sign, otherwise I will not be able to show it. This is your a phi. This is your a phi. So from this point to this point I worked. I need to work a small length in a phi direction. In this direction I need to work. Now there is a small change in phi. There will be a small change in the angle. From phi to delta phi I will go. So from phi to delta phi I am phi to phi plus delta phi I am going. From phi to phi plus delta phi I am going. So there is a change of delta phi angle. So what will be this length? Rho delta phi. or better I should show it with d phi, since this is a small signal change. So I am showing it d phi. So there is a small change of d phi. So what will be this length? Rho d phi. Since I am writing differential length, if I was writing this delta L, then I would have shown delta phi, but I am working d phi. Initial angle was phi, more d phi angle I am working. So this angle is d phi, this length did not change, rho will not change, z will also not change. So how much you have worked? Rho d phi. So this was important. Okay. In phi direction I will work rho d phi, because d phi is an angle, this is not a distance. If you work for d phi angle in phi direction, that means you are working rho d phi distance. I will repeat the statement. If you are working d phi angle in phi direction, that means you are working rho d phi distance. Again, if you are working d phi angle in phi direction, that means you are working rho d phi distance. Is that clear to you? So this distance is rho d phi. In the first lecture itself we saw it, rho and d phi. So this distance will be rho d phi. So in phi direction I am working rho d phi. Very important concept here. Okay, very important. And in z direction what I will work? If I work small signal, sorry, not small signal, again and again I say small signal. So you just, if I say small signal, you consider small length. So if I work a small length in AZ direction, that would be dz AZ gap. So what will be my differential length? So in rho I work d rho a rho cap. In phi I worked rho d phi a phi cap, and in z I worked this much. So this is your differential length. So how will you remember? D rho d phi dz. Again I will show. How will you remember? D rho d phi, and dz is coming towards you. Dz is coming towards you, outward it is, but I need to show like this. It is actually coming towards you, and this is your dz. So in that manner you can remember. D rho d phi dz. This is just a way to remember, nothing else. First you will work d rho d phi dz. Okay, dz is coming towards you. So I will just remove it because it may make you confused when you revise the notes. So just three diagrams are there: d rho d phi, and in z it would be dz only. So this is the differential length. Now let's see locus bit problem, and there we will write down the length as well, that in which direction the length is going. Also we will write down the surface area as well, right? So let's see. All 3 points are fixed. What they are saying, you need to work in rho direction for C1 length, making an angle of C2 degree, and then in the Z direction you need to go for C3. So here you will reach, which is simply a point, So rho C2 degree and C3. So the locus is a point itself, right? Rho is variable, phi is equals to C1 degree and Z equals to C2. Try making all these on your own. Think about it. This C1 degree is fixed. That means this angle is fixed. That angle should be C1 degree. Now your rho could be anything. It could be 0, 1, 2, 3, 4, 5, 6. It could be anything. But height is also fixed. Height is fixed. That your height has to be C2. This height is also fixed. But rho could be anything. What did I tell you? Rho could be anything. 0, 1, 2, 3, 4, 5, 6, 7, 8. Rho could be anything. Actually, this line will be parallel to this. I should have made like this, and height is fixed. The height is C2. Are you getting this point? This is your xy plane. This is your xy plane. This was your z plane. हाथ दुखेगा. There will be pain in hand. Okay, now I will show like this. This is your xy plane. This is your z. Okay. XY plane. This is your z. What was fixed? The angle made with x was fixed. Angle was fixed. Z coordinate was also fixed. But R value was not. Rho value was not fixed. Rho can increase. 0, 1, 2, 3, 4. This height was fixed. The angle was also fixed. That from x axis how much angle will be there. Let's just consider this is your x axis. So from x axis this much angle should be there. So rho will be increasing from here. 0, 1, 2, 3, 4 like this. So it will be a line. Are you getting this point? These things we have seen in the previous lecture as well for Cartesian. Now we are seeing for cylindrical, right? So it is a line only, and I will make it dotted because it can go till infinity, right? Line parallel to arrow I am writing, right? This is the arrow direction, line parallel to arrow. So if I take a small length here, if I take a small length which has a magnitude of d rho, then can you tell me what I will write d rho vector? That will be d rho arrow cap, right? Next one will be more interesting. Try making it on your own. C1 is fixed, right? Rho distance is fixed. That how much distance you need to walk, that is fixed. The height is also fixed. At which height you will walk the distance? You will walk the distance at height C2. At height C2, you will walk the distance C1. But what is the scene? Angle could be anything. Basically, you can start from here as well, from 0 degree as well. You can start. Forget about Z now. Forget about Z for once. Z is just a height. Let's just say Z is 0. Just assume Z is 0. That means we are here. And let's assume this is your C1. Here what is your angle? 0 degree. If I increase the angle, this will come. 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 So in that manner, I am increasing the angle. So what I am going to get? A circle. Are you able to visualize it? I am explaining in the best possible manner that I can. Forget about the Z ones. Okay. Rho is equals to C1, that is fixed. I am assuming my phi is 0 initially. Phi can be variable. From 0 to, phi can vary from 0 to till what? 360 degree. From 0 to 360 degree it can go. So phi is increasing. 0, it is increasing, and here it has reached 360 degree. Now Z is C2. Z is at some height. So this same circle that we made at the ground, the same circle we will get at some height. Are you able to visualize it? XY plane, this is Z. XY plane, this is Z. Okay. C1 distance is fixed. C1 distance is fixed. But phi is variable. From x axis, how much angle you make, that is variable. So 0 degree angle will be here. Then you keep on increasing the angle. You keep on increasing the angle. You just keep on increasing the angle. Then again you reach here. But the same circle you will get at some height, because Z point is also fixed. So the same circle you will get at some height. Are you able to get this point or not? So you are going to get a circle. So your locus will be a circle. Okay. Here phi is variable. This distance I am calling as C1. Locus will be a circle. What will be this length? What do you think? What will be this length? What do you think? If I call C1 is rho, so if I take a small length here, what will be this length? Curved length. If this angle is some phi, what will be this angle? Phi plus b phi. Curved length. The same thing is happening in the air. Are you getting this point? So this length will be rho d phi, right? Rho d phi. This length will be rho d phi. So what will be the vector? If I call this as a length, dl length only, I am calling it as a dl length. So what will be my dl vector? If I take a small length here, what that would be? Rho d phi a phi cap. So electrical guys will be using this a lot of time. There people will be getting confused that, sir, how rho d phi came? So there Anish sir will not be telling you. For EC guys, it might not be that useful, but it is good to build up your concept. But electrical guys will be using it again and again. That there will be a circle. What is the locus? Locus is a circle, right? Locus is a circle. And if I take a small length there, I am calling this length as dl only. dl length. So this length will be rho d phi, and in the direction of phi, in the direction where phi is increasing, a phi cap. So in the direction where phi is increasing, a phi cap. Or you can simply, what you can remember, these 2 points are fixed and phi is variable. Then you just need to write down the small length in phi direction. What is the small length in phi direction? Rho d phi a phi cap. So this is how people mug up. But I am telling you the concept. Like 95% of the students will mug it up. That rho is C1, Z is C2, phi is variable. Okay. Then if I need to write down the small length, then it would be rho d phi a phi cap. This is how they will mug it up. That phi is variable. That means rho d phi a phi cap. Here what was variable? Rho was variable. So d rho a rho cap. That was the small length. Here what is the small length? Rho d phi a rho cap. We will solve the questions in del operator. When we study vector calculus, we will solve the operations. There we will solve the questions. So there I will be taking small length. So again and again I will not be explaining there that how I took this small length, how it will be rho d phi. So you should have that aptitude. That's why I am dealing it here with a very good amount of patience. Right? Let's see more. Try making it on your own. This you can make certainly. Z is variable here. So distance is also fixed and the angle is also fixed. Distance, angle both are fixed. This angle is C2 degree. This distance is also fixed. Z can take any value. Z can take any value. Okay, if I take a small length here, what that would be? If I write it dz vector, that would be dz az cap. If this length is dz, so that would be dz az cap, and I need to show the direction as well. This is the direction, dz az cap. Okay, it will be a line parallel to z axis. So just I will call it, the locus is line. Here the locus is line, here the locus is a circle, here locus is also line. Okay, rho equals to C1. Make the locus of this. Rho equals to C1. What do you mean by that? What is the value of phi? Phi can take any value from 0 degree to 360 degree. And what about Z? Z can take any value from minus infinity to infinity. I told you in the previous lecture, if something is not mentioned, that means it is variable. Here I could have written rho equals to C1, phi variable, Z variable. But in the examination or in the questions, you will not find that they will write down about phi and Z. They will not even mention phi and Z. They will only write rho equals to C1. So you will have to understand that phi can take any value and Z can take any value. Now what is fixed? Rho equals to C1 is fixed. So this distance is fixed. For now, let's just assume that Z is 0. For now, let's assume Z is 0. Z can take any value. So I am assuming Z is 0. Now phi can take 0 to 360 degree. That means it will make a circle here. Right? C1 is fixed. Phi can take 0 to 360 degree. That means it will make a circle. From 0 to 360 degree it will go. It will make a circle. Z can take any value from minus infinity to infinity. So here Z was 0. 1, 2, 3, 4, any value it can take. So it will be a stacking of circles. Circles are being stacked up. And downward as well, circles will be stacked up. Stacking of circles. Circle, circle, circle. In that manner it will be stacked up. What do you think what it will make? Cylinder. But hollow cylinder. Are you able to visualize it or not? Look, I don't have any simulating software. Otherwise, I would have certainly showed you this using simulating software. I tried finding some simulating software, but I could not get it. And secondly, I don't have much time as well. Otherwise, I could have tried something else. But I hope I am giving you the visualization. Again, let's try. I will try showing it. Z-axis, XY plane. Okay, this distance is fixed. Angle phi can take any value, assuming that Z is 0. So if Z is 0, that means I will walk around in this manner. If Z is 0, I will walk around in this manner. 0 to 360 degree. If Z is 1, I will walk around here. If Z is 2, I will walk around here. If Z is infinity, I will walk around here. If Z is minus infinity, I will walk around here. So the circles are being stacked up. The circles are being stacked up. That means it will make a hollow cylinder. right? So I will pause the video and make the hollow cylinder. It will take some time. So I will pause the video and then make the hollow cylinder. Okay, so this is the best I could have made. Okay, I hope this gives a clear picture, but this is how I can make it. But I know you must have got the concept. It will be a hollow cylinder which is spread completely, right? So it is spread completely from minus infinity to infinity. So a kind of hollow cylinder you will see. Okay, try making it. Try making this. The angle C2 is fixed. Angle C2 is fixed. So what angle you are gonna make, that is fixed. That you are gonna make C2 degree. Now what about rho? So this angle is fixed. Forget about it. This angle is fixed. Now if rho is 0, I will be here. If rho is increasing, I will be going like this. And if z increases, then I will be going in this manner. Let's just say here z is 0. Here z is 0, right? So rho will be increasing like this. If z is 1, rho will be increasing like this. If z is 2, rho will be increasing like this. Z is 3, rho will be increasing like this. If z is minus 1, rho will be increasing here, 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 here. So in that manner, a lot of strips will come parallel to this line. So what it will make? It will make a sheet, right? It will make a sheet. This kind of sheet it will make. No. This kind of sheet it will make. So again, let me pause the video. Your time is getting wasted, so I don't want to waste your time. So I will just pause the video and make the sheet. Okay, so this is the diagram I have made. So this was your hollow cylinder, and this was your sheet. Here I did not mark the x, y, z. X, y, z. All are x, y, z only. Okay, we are making with respect to x, y, z only. X, y, z. This is the row length, and this is the sheet we are getting. Now z is equals to C3. Z is fixed. So whatever that will happen at this height, it will happen. At this height, everything will happen. This height is C3, that is fixed. So I need to work C3, and now whatever that needs to happen, that will happen here. Now let us say if rho is 0. So phi can take any value. So phi will go from 0 to 360. So it will be a point only. If rho is, let us say if rho is 1. Rho is 1. This is your rho. This is your rho. So in this direction you are working 1. Now phi can take any value. So phi will walk around like this. If rho is 2, then phi will walk around like this. If rho is 3, phi will walk around like this. Rho is 4, then phi will walk around like this. Like phi can take any value. So it will be a kind of disk, no? It will be a kind of disk. Like rho can be anything and phi can take any value. So it will be a kind of disk. Are you getting this point? Let me show it here. Let me show it here. Everything will happen here. So if rho is 0, it will be a point only. Phi will just walk around here. If rho is 1, then phi will walk around like this. If rho is 2, phi will walk around like this. If rho is 3, so phi will take all the values 0 to 360 degree. If rho is 4, phi will take all the values 0 to 360 degree. So in that manner it will frame a disk, right? So it will frame a disk. This will be a solid disk. It's not. So this, if I am saying disk, that means it is solid only. What do I mean to say? Assume this as circular. Assume this as circular only. Okay, if this is circular, only, and let's just say there is nothing in between, so that will be a circle, right? This will be a circle. This will be a circle. But if I fill it up, then this will be a disk. Are you getting this point? If I have this thing, that is a circle. But if I have something which is filled by something else, so this is your circle, but this is your disk, right? So here it is completely filled because rho can take any value. Rho can go from 0 to infinity. So it is completely filled. So you will make a disk here, right? Let's write down the surface area now. What is the surface here? Here there is only one surface. There is nothing in between. The only surface is this. The only surface is this. I should not make it dotted actually. Just now I am realizing it. This should not be dotted. This should be, because phi can take all the values, no? So this should not be dotted. This would be simply dashed line, not dashed line, hard line it should be. So only surface area is this. Basically it will be like this. Hollow, there is nothing. So this will be the surface area. This will be the surface area. What will be the surface area? Rho equals to constant. First I am telling you how do you write down the surface area by trick. Rho equals to constant. So what will be the direction? Plus minus arrow cap. If arrow is coming, I can write down my DL. D rho arrow cap plus rho d phi a phi cap plus dz az cap. In the last lecture I told you this thing. First you need to see the equation. Rho equals to constant. Rho equals to constant, that means my perpendicular vector will be in rho direction, plus minus arrow cap. Plus minus arrow cap. So forget about this, these two will come. So rho d phi dz. Rho d phi dz. This will be my area vector. Are you getting this point? Can you visualize it? Let me show the visualization. So this is the hollow cylinder we are having. This is our final architecture. Just see, here I am taking a small length. Here I am taking a small length. Yeah, company का नाम दिख रहा है यार. So here I am taking the small length. On this surface, here I am taking a small length. So in which direction I am going? Let's just say if I say I am going in this direction, that means I am moving in phi. Are you able to understand? Phi. Because this one is your z axis, this perpendicular is your z axis, which is coming into the bottle. Now if I say I am walking in this direction, that means I am walking in phi. So in phi I am walking rho d phi. In phi I will walk rho d phi. And if I say I am walking upward, that means I am walking z. So rho d phi into dz. That will be the area. Try visualizing it. This is your hollow cylinder. You need to take horizontal direction and vertical direction. You cannot see it, right? You need to take horizontal direction and vertical direction. If you walk in the horizontal direction, that means you are walking on this curve. If you are walking on curve, that means how much you are walking? Rho d phi. And if you are walking this perpendicular, that means you are walking rho dz. Are you able to understand this point or not? Rho d phi and dz. So this is the area I am. Otherwise, how people can remember it? Rho equals to C1. This is the rho equals to C1. This is our equation. So if rho equals to C1, that means plus minus arrow cap I will get. This is the direction. If plus minus arrow is coming, that means forget about this one. These two will come. Rho d phi dz. Understood? What about this? Can you write down the surface area of this one? First write down how you will write in the examination. You will get to know that, sir, it is phi equals to C2 degree. This particular sheet will be there in front of you. Can you tell me the equation of this sheet? Yes. You will tell that, sir, here the angle is fixed. Angle made from x-axis is fixed. That is C2 degree. That means certainly my area vector will be in plus minus a phi cap. The vector, the perpendicular vector will be plus minus a phi cap. If plus minus a phi is coming, drop these two, just write down d rho dz. This is clearly visible here. This is your d rho and this is your dz. If you take a small length, if you take a small surface area here, that means you are working in d rho and dz. So d rho into dz. This is your ds. D rho dz. Here, what do you see? By this example, bottle. I will work in the curve rho d phi. I will work in the z direction rho d phi dz. Are you able to understand this or not? Right? What about this one? You will work in the curve as well and you will work here as well. If I need to write the surface area, this is the disk. Just consider this as a square. Or what I am going to do is that I can make a circle here. Okay. Okay. Now only consider this circle part. You are not able to see it. Only consider this circular part. So if I need to work in the circular part, that means some curve I need to work and some radius I need to work. Here if I need to work, that means in d rho direction I need to work if I take this small area. So d rho I am working something and rho d phi I am working something. Are you getting this point or not? So d rho and rho d phi. So it doesn't look good. So rho I will put first. Rho d rho d phi. And direction will be az plus minus az cap. Or how you can write down? Z equals to C3. Z equals to C3. What does that mean? Z equals to C3. So my perpendicular vector will be plus minus az cap. So forget about dz, these two will come, rho d phi. So quickly if I need to write down, I will just see the equation. The equation is z equals to C1. If z equals to C1, then area vector will be plus minus az cap, and which all which all small length component will come? The small length component will be rho d phi and d rho. So forget about this dz, rest all the component will come. So if you are just having this dl, then you can write down all the surface areas, right? So let's write down all the surface areas. So what all surface area I can have? So what is my dl? D rho in rho direction. Then I go rho d phi. Then I go dz. Okay. What all surface area I can have? If I say my direction is arrow, then rho d phi dz. If my direction is arrow, what will be the equation? Rho equals to constant. What all it can have? If I say my direction is plus minus a phi cap, then it will be d rho dz plus minus a phi cap. What will be the equation? Phi equals to constant. I am setting up a complete base for your electrostats and magnostats. Those who are watching from electrical and EC guys will be using it in antenna. Spherical coordinate system will be used in antenna. This much will not be used, like majorly it will not be used, but in your vector calculus part it will be used, and that will come for 2 marks for sure. For sure I am saying, for sure 2 mark question will come from there. So useful, it is certainly useful. And what about az? So forget about this dz. So rho d rho d phi, so plus minus az cap. So what is the equation? Equation is z equals to constant. Say yes or no. So this is your summary. And if I need to write down differential volume, so in differential volume all will be multiplied, rho d phi dz. This is your differential volume. This was your differential length. Very, very important. These formulas are very, very important, and generally these are written directly. People wouldn't even know what is the equation of the surface, why this is the equation of the surface, how this surface is coming. Like directly you will see n number of teachers teaching directly these formulas. But how this surface came, how this area came, that is important part. Very, very important part, because in the examination this surface will come and you will not even be able to tell the equation. But now you are much comfortable that sir, here only C3 is fixed. So certainly in az direction I will have the vector. Here directly you can see, no, the vector is in az direction, plus minus az direction, right? So you will be much comfortable in your examination. The lecture might seem a bit typical to you, but in your examination you are not going to be tensed. And those guys who are studying easy lectures in the examination, they will be much tensed. Okay, not offending anyone, just telling the reality. Okay, then this is the differential volume, this is the differential length, this is the differential surface area. Now one small point was left, unit vector conversion. So the way we did the conversion here in the last lecture, this conversion we did, in the same manner you can do the unit vector conversion as well. Unit vector conversion as well. The same matrix will be there. So what I know, x equals to rho cos phi. So ax, how ax can be represented? So ax will be represented some value a rho cap plus some value a phi cap plus some value a z cap. So what all these some value will be? So that I am writing down. Okay. So how will I write down? X equals to rho cos phi. Same matrix is there. Ditto same matrix. X is related with cos. Then y equals to rho sin phi. So here sin phi will come. Z is not related with rho, so 0. Then differentiate. Minus sin phi. Cos minus sin phi. Sin cos phi. This theta, I have this bad habit. This is 0. Here 0, 0 and 1. And then you need to go from here to here, then just take the transpose. Cos phi minus sin phi 0. Sin phi cos phi 0, 0, 0, 1. Okay. So your ax cap is equals to cos phi a rho cap minus sin phi a phi cap plus 0 az cap. Now how this formula came? From the geometry it can come. It can come from the geometry, or how it can come? You write down this expression, x equals to rho cos phi, y equals to rho sin phi. Okay. You take the partial differentiation on both of the side. Do you know how to take partial differentiation? It is simple differentiation only. So you differentiate on both of the side. This will be dx. Here I need to do this thing, right? So how I am going to write it? Cos phi as it is, differentiation of rho. Then rho as it is, differentiation of cos phi. What that will be? Minus sin phi. So here I will put minus sign. Minus sin phi d phi, right? So dx equals to cos phi d rho minus sin phi rho d phi. So if I am working small length dx, that means I must be working in ax direction. If I am working small length d rho, that means I must be working in a rho direction. If I am working small length rho d phi, that means I certainly would have been working in a phi direction. So ax cap is equals to cos phi a rho cap minus sin phi a phi cap. So all the derivation also I am giving from where these things are coming. You should know it. But in the examination you are going to use these two formulas and you will make this matrix. And that there is no harm in making it. Because you should also need to know how to solve the problems in the examination. Only concept is not important. Scoring marks is also important. So that we will develop here. How will I write down dy? So again I will need to do the partial differentiation. So how will I do the partial differentiation? So sin phi as it is d rho. Differentiation of sin phi, that will be cos phi, and then phi as it is cos phi d phi. The differentiation will be cos phi d phi and rho as it is, right? So this will be ay cap sin phi a rho cap cos phi a phi cap. So this is the first expression I am getting. This is the second expression I am getting. What about z? Z equals to z only. X equals to rho cos phi, y equals to rho sin phi, z is equals to z. So dz equals to dz. Partial differentiation I am taking. So if I am working small signal length dz, that means I am working in az direction. Here also I am working in az direction. So az is equals to az. You can match the formulas. You can match the formulas. Well and good. So this is the table. This is the matrix it is coming. You do not need to do this calculation in the examination. Just for your knowledge I am telling the proof how it is coming. but in the examination you will just write down these 2 points and you will be able to write down this matrix. Okay. Now they will ask you the dot product as well. What if they ask you what is AX dot arrow cap? Do you know the answer? AX cap dot arrow cap. Do you know the answer? X rho. What is the angle? Phi. Cos phi. If I just need to calculate this, I am not gonna use geometry here. Okay. If they ask me AX cap dot A phi cap. So do I know the answer? X and phi. What will be the angle? 90 plus phi. 90 plus phi. What will be the answer? Cos 90 plus phi. And what that would be? Minus sin phi. Look, this will be my AX and this will be my A phi. This angle was phi. This angle was 90 degree. Remember it? If you don't remember it, then for that only this is the trick. Just take this here. These just take here and just copy down everything. So in the examination, if they are asking these dot products and you do not remember the answer, they are asking these dot products and you do not remember the answer, you cannot solve it by geometry as well. What you are gonna do? Just close your eyes. What you are gonna write? X equals to rho cos phi. This much at least you will remember, right? Y equals to rho sin phi and Z equals to Z. I just closed my eyes and I wrote down all these things. Z equals to rho cos, X equals to rho cos phi, Y equals to rho sin phi, Z equals to Z. I can write down AX, AY, AZ here. I can write down A rho, A phi, AZ here. Now, X is related to rho by cos phi. Y is related to rho by sin phi. Z is not even related to rho. Here I will just do the differentiation. Minus sin phi, cos phi, 0. Here 0, 0 and 1. There you go. Now, AX cap dot arrow cap is cos phi. AX cap dot A phi cap is minus sin phi. AX cap dot AZ cap is equals to 0. Anything they can ask. A phi cap dot AY cap. AY cap dot A phi cap. But by geometry I remember yaar. This is very easy. A phi, AY. The angle is phi here. So that will be cos phi. So if I have been the student, then I will not be making this particular table or whatever I can say, or matrix also I can say. So if I had been the student, I will not be making it, because this much geometry I can remember. X, Y, rho, phi. This angle is phi. This angle is phi. This angle is 90 minus phi. That's it. Everything is clear. Only thing you need to remember is Z is always perpendicular. So no need to worry. Y, X, phi, sorry, Y, X, rho and phi. AX, A rho, this was angle phi. This was angle 90 minus phi and this was angle phi. This was your A phi. This was your AY. There you go. That's it. This is very easy. Now everything you can write down. And Z is always perpendicular, so no need to worry. AZ cap dot AZ cap will be 1. Now AY dot A phi. AY dot A phi cos theta. Cos phi. AY dot A rho. Cos 90 minus phi. That will be sin phi. That's it. Okay. So very easy it is. So, or you can make this table as well if you are not comfortable with all these things. Right. Now we are going to study about spherical coordinate system. So it will go very smooth because we have studied Cartesian coordinate system in a very in-depth manner. It's been roughly around 2.5 hours we have spent in Cartesian and cylindrical coordinate system only. Now we will study about spherical coordinate system. So now I will take a pause, drink some water, and then we will start spherical coordinate system. So you also do the same. Take some pause and drink some water, pause the video, revise the previous notes, and then come back. Okay. Okay, so let's start studying about spherical coordinate system now. So till now we have seen 3 ways of reaching to the point P. What was the first one? That you walk X, then you walk Y, and then you walk Z. We will reach point P. In the second way, what we did? In the second way, we We directly came here for rho distance, making an angle phi with x axis, and then we traveled z distance. Now what we are going to do, this is the third way. Now what we are going to do is that from the origin we will directly jump to the point P, traveling at distance r. From origin to point P there is a distance r. So from origin to directly we will jump to point P. Okay, but making sure that I make an angle theta with z axis from top to bottom. Very important line. I make an angle theta with z axis from top to bottom. This is my z axis and this is my r. Z axis and r. Z axis and r. Perpendicular, and this is the distance r. So from top to bottom, this is the angle theta. If r goes here, you cannot see. Let's just say this is your z axis, this is your r. So from top to bottom, this is your theta. If r goes here, top to bottom, this is your theta. If r goes here, top to bottom, this is your theta. If r goes here, then look, r was traveling. This was your r was traveling 0. Theta was increasing 90 degree, then increasing 180 degree. Now if r goes here, r started from here and it moved till here. What will be the angle? This will be the angle. R has reached here now, so this will be the angle. Na? You started from here. This was your z, this was your r. Your r started traveling. Now if r reaches here, what will be the angle? No, this will not be the angle. From top to bottom, this will be the angle now. This is again less than 180 degree. So this is the range of theta. I will write down the range of theta and then I will ask you what should be the range of theta. Again I will explain it. So range of theta is from 0 to 180 degree. This is a very conceptual thing. But you got to know one thing, that I need to tell the distance r, making an angle theta with z axis from top to bottom. One more thing I need to make sure. Let's just say if I tell you that you need to jump from origin at a distance r, making an angle theta with z axis. You can jump here as well. That this is the angle theta and I will jump here. So one more thing I need to tell. What I need to tell? The projection of point P on xy plane. Projection of point P on xy plane. This line is making an angle phi. So phi also I need to tell that you need to make an angle of phi with x axis. Your projection P on xy plane should make an angle of phi with x axis. So you need to jump, but jump making sure that you make an angle of theta from top to bottom with z axis, and your projection of point P should make an angle of phi with x axis in anti-clockwise direction. Is that clear to you or not? So this is my point P, this is the distance r. You make an angle theta with z axis from top to bottom. Again I am saying it is not anti-clockwise or clockwise, it is top to bottom. Also what do you need to make sure? The projection of point P, on xy plane, projection of point P on xy plane should make an angle phi with x axis in anti-clockwise direction. This is the projection of point P. Well and good. Or you can say the projection of OP vector on xy plane. Projection of OP vector on xy plane should make an angle of phi from x axis in anti-clockwise direction. So what is your r? R is the distance of point P from origin. So OP vector is simply your r only, right? What is your theta? Theta is the angle made by position vector with z axis from top to bottom. Very important. From top to bottom. Okay. If I need to just tell this is just for general information. What will be your OP cap dot AZ gap? OP cap dot AZ gap. That will be cos theta, right? OP cap dot AZ gap will be cos theta. This phi is regular phi coordinate. This we have studied already in our cylindrical coordinate system. What was your phi? Projection of point P, or you can say projection of OP on xy plane making an angle phi. with x-axis in anti-clockwise direction, right? So what is your arrow? Arrow is the unit vector in increasing direction of r. So let's make all these unit vectors. This will be your this will be your arrow, right? Theta is increasing in this direction, so this will be your a theta. So if I make on this point, this will be my a theta, and phi is increasing in this direction, so this will be my a phi. Theta is increasing in this direction, a theta. Phi is increasing in this direction, a phi, and this will be your ar. So again, if I make on one plane a theta, on one plane I need to make a phi, a theta, and ar. Basically all are perpendicular to each other. Sorry, in this direction it is a phi actually, and this is a theta. Just let me know that what will be your circular diagram. What do you see? Phi cross r is giving me theta. Phi cross r is giving me theta. Or what I can say, r cross theta is giving me phi. R cross theta, you put your hand at r cross theta is giving me phi, right? So r cross theta is giving me phi, and phi cross r is giving me theta. Phi cross r is giving me theta. So this will be the circular diagram. So this is a phi cap, ar cap, and a theta cap. So if I ask you what is your ar cap ar cap cross a theta cap, that will be a phi cap. So three coordinates are there, r, theta, and phi. Phi in this direction. So this I should have made better. This I can make better. Phi will be in this direction, so it will be somewhat like this, increasing here, somewhat like this I can make. And this is your point P. So first I will call r, theta, phi. In that manner it is written, r, theta, phi. Point P, it was x, y, z. In cylindrical what it was? R, phi, z. In spherical what it is? Sorry, not r, it was rho. Rho, phi, z. In spherical what it is? R, theta, phi. R, theta, and then phi. And this is the cyclic order, ar, a theta, a phi. This is the cyclic order. Well and good. These are the unit vectors and very basic things these are. Now what is the range? What is the range of r? What do you think? From 0 to infinity. Because r will be increasing. From 0 to infinity it can go. It cannot be negative. From 0 to infinity it can go. So 0 as well it can be. What about phi? Phi is the regular coordinate. So phi is the same coordinate that will go from 0 degree to 360 degree. What about theta? What will be the range of theta? Very important concept, okay? Let's come here. What did I tell you? What is your theta? Angle made from, this is your OP vector, this is your Z axis. Angle made from Z axis towards OP vector from top to bottom. Angle made from Z axis, sorry, angle made between OP vector and Z axis from top to bottom. From Z axis to bottom. From Z axis to OP vector. Three language I am telling. Angle between Z axis and OP vector from top to bottom. This is the definition of theta. This you can see here. Angle made by position vector with Z axis from top to bottom. Now, this was your R, or you can say OP vector. Now OP vector is going down here. So what is happening? Theta is increasing. Theta is increasing. Here theta is increasing. Theta has increased to 180 degree. Now theta is 180 degree, right? Theta is 180 degree. Now, if OP vector comes here, this OP vector is moving around. Now I am saying that OP vector has come down to this path. So let's see it here practically. This is your Z axis. this is your z axis, and this is your OP vector now. So will you measure the angle from here? Will you say that, sir, this will be the angle? Will you say that, sir, from here to here, this will be the angle? No, this will be the angle. No. What did I tell you? From top to bottom, from z axis towards OP vector. This is the definition. From top to bottom. So what will be the angle? Less than 180, no? Basically, it would be somewhat greater than 90 and less than 180. And if it comes here, it will be 90 degree. If it goes like that, it will be 0 degree. So just try imagining that this OP vector can move like this, or it can move like this. In this circle only you need to imagine. This take the radius r and not circle, sphere. Take this radius r and try to move it. So 0 to 180 degree it will go, 0 to 180 degree it will go. On all the side from 0 to 180 degree it will go. Are you getting this point or not? Or shall I explain it again? Z axis, OP vector. Angle theta increasing, reaches 180 degree. When it reaches here, how I will measure the angle? From top to bottom. So it is what? Again less than 180 degree only. It can be somewhat around 120, 150, I don't know, but certainly it will be less than 180 degree. So what is the range of theta? Range of theta is from 0 to 180 degree, and you will include 180 degree here. Certainly you will include 180 degree. If this is z axis, this is your OP. What is the angle? 180 degree. So certainly you will include 180 degree here. Well and good. So these are the range. Very important, like a lot of guys get confused here, that why the range is from 0 to 180 degree, why it is not 360 degree. Right? Now tell me what is the answer for this? 1. 1. 1. What is the answer for this? 0. Because all are perpendicular to each other. This is your AR, this is your A theta, and A phi is in between. So all three are perpendicular to each other, that we know. AR dot A phi 0, A phi A theta dot A phi 0, all are perpendicular to each other. This is cross product 0, sin 0 is 0. What is the table? Not table. What is this circular diagram? R theta phi. R theta phi. So AR cross A theta is A phi. A theta cross A phi is AR. A phi cross AR is A theta. So what they are asking, AR cross A theta is equals to A phi. A theta cross A phi is equals to AR. AR cross A phi. A phi cross AR will give me A theta. AR cross A phi will give me minus A theta. Opposite. So minus A theta. Right? So that's it. Vector representation. How will you get AR? How will you get AR? You will get AR. What is AR? If I am going in vector A, then how much distance I am traveling in rho direction? Distance traveled in rho direction, arrow direction. Wait a minute, sorry. R theta phi. So what is AR? AR is the distance traveled in AR direction. What is A theta? Distance traveled in A theta direction. What is A phi? Distance traveled in A phi direction. So how will you get AR? AR will be A vector dot AR cap. What will be A theta? A theta will be A vector dot A theta cap. What will be A phi? A phi will be A vector dot A phi cap. Well and good. This is your AR, A theta, A phi. Dot product, what it will be? अरे यार ये सब चेंज करना ही भूल गया हूँ मैं. These should be changed. R theta phi. R theta phi. R theta phi. AR BR. A theta B theta. A phi B phi. Right? This is the dot product, and this is how you can get AR, A theta, A phi. Well and good. Everything is crystal clear. Cross product. So R theta phi. What I am gonna write here? sorry, A cross B you need to do. So AR, A theta, A phi, BR, B theta, B phi. So A cross B I will get. So A cross B will be AR cap A theta B phi minus B theta A phi. A theta cap will basically you need to solve this matrix now. So AR cap A theta B phi minus B theta A phi. A theta cap AR B A theta cap A phi BR minus AR B phi A plus A phi cap AR B theta minus BR A theta. Well and good. So you can solve this matrix as well. Not matrix, determinant. Now conversion. Let's see the conversion now. So from Cartesian to spherical we are going. So I need to find the relation x and r theta phi, y and r theta phi, and z and r theta phi. This relation I need to find. Okay. So let's do it very easy. This is your r. This angle is theta. What this angle will be? 90 minus theta. How do you know it? This is my xy plane, this is my z. This is my xy plane, this is my z. XY plane z. This is r. It is making angle theta with z axis. So it will make 90 minus theta with xy plane. And this line is there in xy plane only. Z axis r theta. So this will make 90 minus theta with xy plane. So 90 minus theta. So r cos 90 minus theta. So this distance will be r sin theta, right? R cos 90 minus theta, that will be sin theta only. So this distance is r sin theta, and component of this along x direction. Basically, component of this is this with along x direction will be r sin theta cos phi. Are you getting this point or not? Basically, if I need to reach the point P, how I can work? In x direction, in y direction, and then this is my z direction, right? Or how I can work? I work for rho. I work for rho and then z, making an angle theta. Sorry, making an angle phi. Or this way I can go, making an angle from top to bottom theta and from here to phi. Are you satisfied with all these things, right? Now this is your r. On xy plane it is having component r sin theta. This component is r cos 90 minus theta, that will be r sin theta. This is r sin theta. On x axis it is having r sin theta cos phi. So x is r sin theta, and what is the component here on x axis? R sin theta cos phi. What about y? So r sin theta is same. This line is r sin theta. There is no doubt about that. R sin theta. But on y direction, what is the component it is having? Sin phi. Basically, if it is phi, that would be 90 minus phi. So that will be sin phi. This, what is this? This is rho only, no? Are you getting this point? This is r sin theta. This is rho only, no? Rho equals to r sin theta actually. This distance is rho. Now, what was your x? X was rho cos phi. And what was your y? Y was rho sin phi. Do you agree to this point? Rho cos phi, rho sin phi. And rho is r sin theta. That's it. This is actually rho only. Projection of OP vector on xy plane, that was rho. So this is rho only. R sin theta is equals to rho. Okay. And what is z? What is z? Tell me. Z is r cos theta. Component of r along z axis, that is r cos theta. So z is r cos theta. Are you getting this point? Again, let me explain. This is r sin theta cos phi, r sin theta sin phi, r cos theta, right? What about this rho? Rho is r sin theta, phi is phi only. Phi is same. Rho phi z, and what is z? Z is r cos theta. There you go. Okay. So these are the coordinates. Now I need to convert to the other side as well. I need to find the value of r. What do you think? What will be the value of r? R is simply the magnitude of OP. So R will be root x square plus y square plus z square. Or from here also you can see, if you do x square plus y square plus z square, what you are gonna get? R square only. X square plus y square plus z square. What that would be? R square sin square theta cos square phi. R square sin square theta sin square phi. Cos square theta sin square theta will be 1. Sorry, cos square phi and sin square phi will be 1. So here you are gonna get R square sin square theta, and this will be your R square cos square theta. So what you are gonna get? R square only. So R will be root x square plus y square plus z square. Or from geometry as well you can see, this will be simply the R. This is simply the magnitude, so that will be root x square plus y square plus z square. What about theta? What will be your theta? So for theta, what we can do is that I need to find theta. So one thing I can see here is that my x square plus y square, root x square plus y square is equals to r sin theta. Do you agree to this point? And what is my r cos theta? That is z. So can I do like this? If I divide both of these equations, this equation and this equation, if I divide both of this equation, what I am going to get? Tan theta is equals to root x square plus y square divided by z. So my theta will be tan inverse root x square plus y square divided by z. Did you understand this? Just I made the square. So r square sin square theta cos square theta plus r square sin square theta sin square phi is equals to x square plus y square. So cos square phi and sin square phi will be 1. So r sin theta is equals to root x square plus y square, and this is your r cos theta. So tan theta is equals to root x square plus y square divided by z. So from there theta is equals to tan inverse this. Now I need to find phi. So what I can do? Phi I can see very easily. I need to find phi. So what will be my phi? Phi is tan inverse y by x. Phi is tan inverse y by x if you just divide these two equations, or phi is the same as the previous one. So phi did not even change. So phi is tan inverse y by x. So these things you are not gonna mug up. You will derive it very quickly. You will write down, okay sir, what will be x? R sin theta cos phi. Y will be r sin theta cos, r sin theta sin phi. What will be z? R cos theta. From there you can derive r as well, theta as well, and phi as well. So directly you do not need to mug it up. Okay, you will derive it in the examination very easily. You will be able to derive. It will take very less time. Now let's go from here to the other side. So what will be your r? What do you think? From geometry as well you can tell, and from these two equations as well you can tell. It will be root rho square plus z square. Because what is your rho square? Rho square is x square plus y square, right? Rho square is x square plus y square. So from here also you can tell it is simply, if you just square both of the equation, rho square plus z square is equals to r square. So r is equals to root rho square plus z square. What is your phi? First we will write down theta. So how will you get theta? Just divide these two equations. So you will get tan inverse rho by z, right? And rho is root x square plus y square. So from here also you can verify. And what is your phi? Phi is the same phi only. So there you go. These are the expressions. So just see it and forget it. In the examination you are not going to mug it up. In the examination you can derive it. Okay. So these are the point convergence. Now convergent matrix. Directly I am gonna write matrix now. You can derive it if you want to. What I am doing, I need value of Ax. So how will I get Ax? My Ax will be vector A dot Ax cap. So for that I need to do AR arrow cap Ax cap plus A theta. अरे यार यहाँ पे भी नहीं चेंज किया. Okay, so y arrow, here it would be AR Ax cap plus A theta Ax cap plus A phi a phi cap dot ax cap. Look, these are easy. This is also easy, but this is a bit tough through the geometry. Let me show you. Okay, no need to worry. I will show you. This was your R. This R was making some angle 90 minus theta with your xy plane. 90 minus theta with your xy plane, right? And this was your x, and this was your y. This was your xy, and this was your R. Actually, R I can show something like this. R was somewhere here. It is in the air. Okay, it would be very tough to show in the air. How can I show it? Oh, let's go directly here. No, why to worry? Let's go directly here. This is your R. Here it will make R cos theta. This is my R sin theta. And if I need the component across x, so R sin theta cos phi. So what will be my ax dot ar? First component is sin theta, then cos phi. So sin theta into cos phi. Are you getting this point? Where is the conversion? Yeah. So this will be my AR cap. This will be my AR cap. So first component I will take across rho. That will be, if I take the component across the rho, what that would be? Sin theta. Because cos 90 minus theta is sin theta. Sin theta cos phi. So you don't need to worry. Like you can write down this value is very easy. No, this is tough. This is very easy. A phi ax. What that would be? A phi dot ax cap. What that would be? Cos phi only. This will be cos phi. This also I have explained. 90 minus theta. So sin theta and then cos phi. Sin theta cos phi. But in the examination, how you are going to write down? X equals to what? What do you know? X is equals to R sin theta cos phi. Y equals to what do you know? R sin theta sin phi. And Z is equals to Z. Sorry. Z is equals to R cos theta. Okay. Now X to R I am going. X to R I am going. Okay, I am fine. So X has dependency on R. So sin theta cos phi. Y has dependency on R. Sin theta sin phi. Z has dependency on R. Cos theta. Now when you were in school, what did you learn first? Theta or phi? In 10th class, we had exercise 8, right? Where we studied about trigonometry in exercise 8. So there we used to introduce theta, right? Tan theta, cos theta. Phi came later on. When we were kids, when we were in 10th class, there first we studied about theta. So what we studied about first? Theta. So first you will differentiate with respect to theta. Okay. Here you will differentiate with respect to theta first. So sin theta, cos theta, and phi component will be as it is. Sin theta, cos theta, phi component will be as it is. Cos theta minus sin theta. Is that clear to you? Right? Now if you have already done the differentiation with respect to theta, then forget about theta. Now do the differentiation with respect to phi. Okay? Do the differentiation with respect to phi. And forget about cos theta, anything. Just forget about that. What you are going to get here? Differentiation of cos, what that would be? Minus sin. Differentiation of cos, this will be sin only, no? Differentiation of sin, because I am not changing this, cos, sin directly. Differentiation of sin, what that would be? Cos. And differentiation of sin theta with respect to phi, that would be 0. Did you understand how did I write this table? Ax, Ay, Az, Ar, A theta, A phi. X equals to R sin theta, Y equals to R sin theta sin phi, Z equals to R cos theta. This I already know. x has dependency on r, sin theta cos phi, y has dependency on r, sin theta sin phi, z has dependency on r as well, cos theta. In basic elementary classes in 8th class, first we studied about what? We studied about theta. So first I will differentiate with respect to theta. Sin theta, cos theta, sin theta, cos theta minus sin theta. Cos phi, sin phi, sin phi. Okay. Here there was no phi component, so I did not hamper it. Now I need to go to phi differentiation. When I am doing the differentiation of phi, I will forget about the theta component. So here cos phi will be differentiated to minus sin phi will be differentiated to cos phi, and this will be 0. So this is how we will remember the table. It is not tough to remember. Here also you can check sin theta cos phi. Okay, sorry. This was actually minus sin phi. Very sorry. This was actually minus sin phi. No, I thought of it as arrow. A phi, that would be heavy angle 90 plus phi. So that would be minus sin phi. This would be minus sin phi. Really sorry for the error. And this would come out to be cos theta cos phi. This would come out to be cos theta cos phi, which is tough to visualize. If you want to visualize, if you have the time, then you can visualize it. If I start explaining it here, it will take 20 minutes. So that's why I am not wasting any time here. Okay, you can visualize if you want to. It will come out to be cos theta cos phi. Here I can see sin theta cos phi, this I can see, cos theta cos phi, this I can see, this is minus sin phi. So this is the table. Now if I need to write down the other one, so just I need to take the transpose. So from here to here if I need to write down, then this relation I already know. Now I will write down this relation horizontally, because opposite I am going. Sin theta cos phi, sin theta sin phi, and cos theta. Now first I will differentiate with respect to sin theta. So I will get, sorry, with respect to theta. So sin theta differentiation will be cos theta. This will be cos theta, and this will be minus sin theta. Now I will differentiate with respect to phi. So I will forget about cos component. So cos phi will be done to cos phi will be done to minus sin phi will be done to cos phi, and this will be done to 0. You can see it is just the transpose, nothing else. Cos phi sin phi minus sin theta cos phi cos theta minus sin phi. Okay, very easily I can write down the relation. Very rarely it will be asked in the examination, but even if it is asked, then we can write down all the relation, right? What about these relation now between rho and r? From where to where I am going? From where to where? Cylindrical to spherical. So again I know the relation. Rho equals to r sin theta, phi is equals to phi, z equals to r cos theta. So rho phi z, r theta phi. Rho phi z here. In what manner I write? Rho phi z, r theta phi. So same thing I have written here, and this is the opposite. So from rho to r I am going. So I will write vertically now. So rho has relation with r, sin theta. Phi has any relation with r? 0. Rho equals to r sin theta, this we know. Phi is equals to phi, and z equals to r cos theta, this also we know, right? Everything is crystal clear here. Z has relation with r, yes, cos theta. Now differentiate with respect to theta. So what I am gonna get? This is sin theta. So what is the differentiation? Cos theta. 0. What is the differentiation? Minus sin theta. Always if you get confused between the differentiation, so what I told you, sin theta differentiation positive, so cos theta, and cos theta differentiation slope negative, so minus sin theta. In the first lecture I told you this thing, that it happens with me in the examination. I always get confused that what will be the differentiation of sine, minus or plus, minus cos theta or plus cos theta. So I just think, okay, slope will be positive, so plus cos theta. Then what will be the differentiation of cos? So cos, slope will be negative, so minus sin theta. Okay, and here again differentiation I will not do. This will be 0, this will be 0, whole row cannot be 0, so this will be 1. This is same like first matrix that we solved. First matrix means between Cartesian to cylindrical. So there also we were getting one term only. So there first we differentiated, then there is nothing to differentiate, so 0. Nothing to differentiate, so 0. Whole row cannot be 0, so this will be 1. That's it. Now I just transpose I need to take. Sine theta and 0. Okay, so transpose I have taken. But these are easy. Basically, if I ask arrow dot AR, can you tell me what that would be? Rho and R. What is the angle? This is rho. This was your R and this is your rho. What was your angle? 90 minus theta. So what you will get here? Sine theta. Yes. Right. This is easy. In the examination, like if they are asking me this thing, that what will be my A5 dot AR cap. So what I am gonna think? Where is my A5? Okay, this will be a bit tough. No, it will not be tough. A5 and AR cap. A5 and AR cap. No relation. 90-degree angle will be there, no? Because A5 and AR are perpendicular to each other. R theta phi. Phi and R are perpendicular to each other. So AR dot A5 will be 0. AR dot A5 will be 0. Right? So this I can think. In the examination I can think. It is not that tough. If I need to think of AZ dot AR, how will I think? AZ dot AR. What is the angle? Theta. So answer will be cos theta. So AZ dot AR cos theta. So we will solve the problems in the next lecture itself. We are going to solve a lot of problems. So there we will see, without even applying any metrics and all, we are able to solve most of the problems, 90% of the problems. And in the examination as well, the question paper will set the problems such that you are able to do it quickly. If someone makes the matrices, then he will take some time. But if someone is having good aptitude, then AZ dot AR, that will be cos theta. So in the examination, they will be framing the problem in a manner that the one who has studied the concept in a deeper manner, that guy will be able to solve it quicker. Okay. So in the examination, rarely you will have to make this matrix, but you should have an idea how to make this particular matrix. It is very simple. I have told you the trick. Rho phi z, sin theta, 0, cos theta, differentiation, and then last row cannot be 0, and then simply here you take the transpose. Right. Now, dot product. What is this? This is dot product. So AX and AR. X equals to R sin theta cos phi, Y equals to R sin theta sin phi, and Z equals to R cos theta. This I know. So X to R I am writing. So I will write horizontally. X has relation with R, sin theta cos phi. Y has relation with R, sin theta sin phi. Is the same matrix I am writing, nothing else. Dot product, dot product. And Z dot AR, it also has a relation cos theta. What I need to do? Differentiate with respect to theta first. So what I am gonna get? Cos theta cos phi, then cos theta sin phi, and then minus sin theta. Now I will differentiate with respect to cos, and I forget about theta. Okay, so cos phi will give me minus sin phi, sin phi will give me cos phi, and this will give me 0. What about this? Rho equals to R sin theta. Phi has no relation, and Z equals to R cos theta. Differentiation, sin theta will give you cos theta, and cos theta will give you minus sin theta. This will be 0, this will be 1, and this will be 0. These are the relation. Very easily I can write it down. Okay. Now let's see small length. Small differential, basically differential length I need to write down. So I will work small length in all the direction. So in R, if I am working small length, so this is simply a distance. This is my R. If I am working small length in AR, that would be dr only. So dr AR cap. But if I work some length in angle, that will be interesting. Okay. So if this was my R was fixed here. My phi was also fixed here. Now I am working some distance in theta direction. So phi was also fixed. I told you this thing. When you are working in theta direction, that means R and phi will be fixed. R and phi will be fixed. Now you are working in theta direction. This was your theta. Now if you work a little bit in theta, that means you must have worked for you must have worked for d theta angle, right? So what will be this distance in the direction of theta? How much you have worked? R d theta. Say yes or no. In the direction of theta you have worked r d theta. So you have worked r d theta in the direction of theta. What about in the direction of phi? In the direction of phi, how much you worked? Rho d phi. Basically, in the direction of phi, this was your rho. Rho is actually here, rho is r sin theta. Here the rho is r sin theta, right? Rho is equals to r sin theta because this was your r, this was your theta angle, so this was 90 minus theta. So rho is r sin theta, and you are working how much? By phi angle. Initially phi was fixed here, which was, let's remove it off once. Initially phi was fixed. Now you are working d phi. What will be this length? This length is r sin theta. This length did not change. This is also r sin theta. So how much will be this length? R sin theta d phi. R sin theta d phi. Or you can say rho d phi. Or you can say r sin theta d phi in the direction of rho I am going. So this much length I worked, this much length I worked, and this much length I worked. So what will be my dl? In the direction of r I need to work ar cap. In the direction of theta I need to work r d theta, and in the direction of rho I worked r sin theta d phi. R sin theta d phi. You will remember it by rho d phi. Rho d phi. Rho is r sin theta. So r sin theta d phi. Okay. So you just need to keep it in your mind. Your dl is, what is your dl? dr ar cap, dr ar cap. If you work in the theta, that will be r d theta a theta, and if you work in phi, that will be rho d phi, and rho is r sin theta. So r sin theta d phi. So this you need to remember, and you will be able to remember it very easily. dr r d theta r sin theta d phi. I hope you are not getting confused with the formula. In the end we will write down all the summary, but these, like, I am giving my level best so that you can remember these formulas. Like, I am not asking you to mug it up. There is a way. dr r d theta r sin theta d phi. So you will be able to remember it. Locus based problem, let's see. Here I am not telling that point problem that r is fixed, theta is fixed, and phi is fixed. So that will make a point. So that I did not pick here. I hope you must have understood. R is fixed, theta is fixed, and phi is fixed. So that will make a point, right? So that problem I am not taking here. I am directly starting from the line. So r is variable, theta is fixed. Basically, this angle is fixed. This angle is fixed. This angle is fixed. That is C2 degree. This is fixed. Now this is also fixed, that whatever the projection you take, how much angle this will make. This is also fixed. This angle is also fixed. That is C3 degree. But r is variable. So r can be 0 and it can increase in this manner. So in which direction it is increasing? In which direction it is increasing? Let's just say this is a small signal length and I say it is increasing in this direction. So what I will call it? dr ar cap. If I take a small length dr, so it is increasing in ar direction. In which direction it will increase? Theta is variable. So it will increase in the theta direction. Let's see it. So r is C1 and theta is variable. R is C1 and theta is variable. And phi is C3. That is also fixed. What is the scene? That your r is fixed and whatever the angle it is making with your xy plane, this angle is also fixed. What is variable? Theta is variable. So theta can take from 0 to 180 any value. Are you getting this point? So this is how your theta will be. Let me explain it again. I know you did not understand it. xy plane z. Okay. Now my r is fixed. R could be C1. Let's just say my theta is 0. If my theta is 0, this is what I am assuming. My theta is 0 and this my r is fixed. And how much angle it is making with x-axis, that also I am assuming it is 0. Because C3 can be anything, no? This I am assuming 0 only. Now what will happen? That theta can increase now. Theta can take 0 degree, 10 degree, 15 degree, 90 degree, here 90 degree, then 95, then till 180. So what is happening? From here to here it will make a semicircle, from here to here it will make a semicircle, from here to here it will make a semicircle. Around z axis everywhere it will make the semicircle. Did you understand this point? What is a sphere? This is a sphere, right? This is a sphere. This is a sphere and this is the z axis. Just think this is the z axis. This is a z axis. This point is a z axis. From z axis and origin is right in the middle. So from z axis there are all the r distance. R distances are there from the origin. And this is the theta. If I go on this line, this is the theta. Theta can start from here 0 degree and increasing 90 degree, and in that manner it can go up to 180 degree. Are you able to understand this point or not? This is your z axis. Just consider this as the z axis. This is your 0 degree angle. It will increase till 180 it can go. Here as well from 0 to 180 it can go. In this side as well 0 to 180 it can go. In this side as well 0 to 180 it can go. So from z axis it will make a lot of semicircles. Are you able to visualize it or not? Again I am explaining. This is z axis. I know a lot of people will be getting confused here. This is a z axis. If you are able to understand, then just move to the next part. This is a z axis and r is fixed, the angle is fixed. Just the thing is my theta will be varying. Here it is 0 degree. Now it will start varying 0. This could be anything. Then this will come 90. Then it can go up to 180 degree. Here also it will do the same thing. Here also it can go up to 180 degree. Here also it can do the same thing, 180 degree. Here also it can do the same thing, 180 degree. So a lot of semicircle arc it will make. This is not only one arc it will make. A lot of semicircle arc it will make. Are you getting this point? On the sphere of this, on the perimeter of this, on the surface area of this, I should not say perimeter, on the surface area of this sphere, there will be arcs. These are semicircle arc. A lot of semicircle arc it will make. Are you getting this point or not? Right? So this is a semicircle arc. Semicircle. Okay. And if I take a small length here, so in which direction I am moving? In theta. So in theta direction, how much I move? R d theta. In theta direction, how much I move? R d theta. So this will be R d theta. R d theta, and if I need to write down the vector, that will be R d theta a theta. Let's write down this one. Phi is variable. Theta is also fixed. R is also fixed. Basically, these things are fixed. This is your R, this is your point P, and this theta is also fixed. What is variable? Phi is variable. So phi can be basically here. Phi is the angle made with x-axis. So it could be 0 as well. It can be starting, it will make a circle. Are you getting this point? If phi is variable, it will simply make a circle. Z axis it is here. Okay. Let us assume point P is here. If point P is here with x axis, how much angle it is making? 0 degree. Point P will start moving from 0 to 360 degree angle it will make. This is some angle, right? This is some angle. It can actually make this much of angle. So it will simply make a circle, right? It will simply make a circle here. This exactly the same example we took in our previous Cartesian coordinate as well, right? It will make a circle only. So if I am moving in theta, how much I am moving? R sin theta. If I am moving in phi, so how much I am moving? If I am moving in phi, I am moving r sin theta d phi. So this will be r sin theta d phi. The small length will be r sin theta d phi. Okay, r sin theta d phi. Okay, and I can go in arrow direction. Are you getting this point? This will be a circle, right? If phi is moving, this will be a circle only. If phi is moving, this will be a circle. This is your phi. If that is moving, that will make a circle only. And if you are moving in the direction of phi, then you will move r sin theta d phi. How will you remember? You will remember it by rho d phi. Rho d phi. Rho d phi I am going. And rho is my r sin theta. This is my 90 minus theta. So r sin theta. Okay. Let's see this. Now my r is constant and theta is variable. Phi is also variable. R is constant. Single thing is constant, that is r. Forget about this. If I know these things, r is constant, theta is variable and phi is variable. Can you write down the surface area? Can you let me know the surface area? R is constant. That means my unit vector perpendicular will be plus minus AR cap. What is my DL? DL is dr AR cap plus r d theta a theta plus r sin theta d phi a phi cap. Right? dr AR cap plus r d theta a theta cap plus r sin theta d phi a phi cap. AR is coming. Forget about this. What will be the answer? R square sin theta d theta r d theta into r sin theta d phi. So r square sin theta d theta d phi. R square sin theta d theta d phi. Are you getting this point? This is how I will take the surface area. But let's make the trajectory that how will the surface look like. So r is constant. R is constant. This is constant. Theta is variable and phi is also variable. Try thinking what you will make. R is constant. Okay. So theta I am starting from 0. From 0 to 180 I go. And phi can also vary. This is your theta. 0 to 180 it is going. And what about phi? Phi will walk around like this. So it will make a hollow sphere. R is fixed. R is fixed. Okay. Theta can go from 0 to 180 in this direction, 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 0 to 180 in this direction. In all the direction it can go 0 to 180. And what phi will do? Phi will start from 0. This is my x-axis. Phi will start from 0. It will rotate like this. This is my x-axis. This is my x-axis. Phi will rotate like this. So it will make a hollow sphere. Are you getting this point? R is fixed here. Phi will vary and theta will vary. So it will make a hollow sphere only. Okay. So how I am going to show it? I am going to show in this manner that my theta is varying. In all the direction, in this direction as well. This is a sphere. So my theta is varying like this as well. My theta is varying like this as well. My theta is varying like this as well. Okay. And in the previous slide as well, my theta is varying. One more line I will do. My theta is varying like this as well. So everywhere my theta is varying. And previous as well, my theta is varying. Along with that, my phi is varying in this manner. In the whole circle. So in the whole circle, my phi is varying. In the whole circle, my phi is varying. So this will make a hollow sphere. In the whole circle, my phi is varying. Right. So this will make a hollow sphere. I hope you are able to visualize now. What is this? Yeah. So here R is variable, theta is fixed. From z axis you will make a certain angle that is fixed, that is C2 degree. So not just on this side, from this side as well. This is your z axis, this is your z axis. So from z axis you will make all around C2 degree only. From here to here, all around C2 degree, all around your C2 degree is there. Okay, but phi can vary, phi can vary. So phi can be 0 degree as well. R and phi both can vary, right? Phi can be 0 degree or phi can be very less. Basically, this is my R, here this is my R, and phi is varying from 0 to 360 degree. Now this is my R, phi is varying from 0 to 360 degree. Now again this is my R, phi is again varying from 0 to 360 degree. Now this is my R, phi is again varying from 0 to 360 degree. What do you think what I am getting? A cone. Very important for ECE student. In antenna I will be using it. Okay, ECE student, very important. It will be a cone. How it will be a cone? This is z axis. What is fixed? Angle is fixed. Theta equals to C2 degree, angle is fixed. R can vary. Let's just say R is this much. If R is this much, then what will happen? R is this much. Phi will take from 0 to 360 turn. From 0 to 360 degree turn, phi will take. Now R is this much. From 0 to 360 degree turn it will take. R is this much. From 0 to 360 degree turn it will take. R is this much. 0 to 360 degree turn it will take. So this R I want to increase. So this will keep on going. It will keep on going. So it will make a cone. Okay, and then again these like these circles will keep on going like that. Here also there will be circles. Every circle I am not making. There will be circles here. Okay, so it will be a hollow cone. This is your hollow sphere. This is hollow cone. If I take a small area, can I write down the surface area here? What is fixed here? Theta is fixed. So A theta, R sin theta, dr d phi, right? So what will be the unit vector? That will be plus minus. Look, visualizing it a bit tough, but if you want to visualize, just try taking a small area here across the cone. So in what direction you are moving? In phi you are moving. If you move in phi, then how much you move? R sin theta d phi. If you move in phi, then how much you move? R sin theta d phi. And where else you are moving? You are moving in R. And if you move in R, how much you move? dr. So R sin theta d phi into dr. That's it. R sin theta, better I should have written in this manner only. R sin theta d phi into dr. And what is the unit vector? That will be plus minus a theta cap. Okay, well and good. So let's move to the last one. So R is variable, theta is variable, and phi equals to C3 degree is fixed. So phi equals to, just wait a second, I am my head is revolving around, so I need to wait a second. Okay, then we will continue. Okay, so did you solve it? What you are gonna get? A semicircle disc, right? Like this C3 is fixed, this angle is fixed. Now R can be anything. If it is 0, there is no sense. If it is 1, if R is 1, then theta can make 0 to 180 degree angle. So from 0 to 180 degree angle. If R is 2, if R is 3, 0 to 180 degree. R is 4, 0 to 180 degree angle. R could be 0.5, anything, 0 to 180 degree angle. So this disc we will get. Basically this was your z axis. This angle was fixed only. This angle was fixed. So R could be varying. R, let's just say R was 1. Here I am showing only this angle was fixed. On this angle it was fixed. R was 1. R was 1. And now theta can vary from 0 to 180 degree. 0 to 180 degree. 0 to 180 degree, 0 to 180 degree. R is increasing. Here it was 1, 0 to 180 degree, 0 to 180 degree, 0 to 180 degree. Just hold it like this, 0 to 180 degree, 0 to 180 degree, 0 to 180 degree, 0 to 180 degree. So this disc I am gonna get. This C3 angle is fixed, right? So am I making it correctly? Okay, this doesn't feel like a correct diagram because C3 angle I need to show fix. So this doesn't seem like a correct diagram. Let me make it correct. Okay, it is fine only. You just need to know that this distance is r. These all the distance are r. These are the r distance. Like for this particular waveform, for this last waveform, this is the r distance. This is the r distance, and every time it is making C3 degree. So yeah, this diagram is correct only. Okay, there is no doubt about that. One blunder I did here, where I did here, I told you that there will be many semicircle strip, right? This is what I told you, but that's not the case. Why is that so? There will be only one semicircle strip only, because C3 is this angle phi is fixed, no? If I say that across z axis there will be many strips, so what do I mean by that? That my C3 is changing. My C3 is changing, then only I can have many strips. If I am having many strips, then what it will make? A hollow sphere. So here what was changing? Theta was also changing and phi was also changing. Here what was the scene? Only theta was changing, phi was not changing. So a lot of strips, let's just say around z axis, if I get a lot of strips, so that will make a hollow sphere only, no? So here I got the hollow sphere only. But here what did you get to know? That C3 is fixed here. This angle C3 is fixed. So only one you are gonna get. So that blunder I did here. Only one semicircle strip you will get. Only one we will get. Okay. So that was an error from my side. So when I took this example, then I thought of it. That if C3 is fixed, here also it was fixed. So only one strip you are gonna get, no? And here R is also variable. So in this direction, a lot of strips I am getting. A lot of strips I am getting if R is also variable. Okay. So this was the example. And here if I need to write down the small area, so phi is fixed. So A phi is fixed. What is the length? This is the length. Forget about this. These all will come. R dr d theta. So this will be my R dr d theta A phi. A phi cap. So this I can write down here. So this will be your ds. Okay. Now, what is the summary? Summary is, what is my dl length? What is my dl length? Dl length is dr I will work in r, in theta I will work r d theta, and in phi I will work rho d phi. In phi I will work rho d phi. And what is rho? Rho is r sin theta d phi. So in phi I will work this much. What is my surface area? That is, if I talk about r only, ar cap, then it would be r square sin theta d theta d phi plus minus ar cap. If I talk about a theta only, so that will be r sin theta dr d phi. If I talk about only a theta, and if I talk about only a phi, so that would be r dr d theta. And what will be the differential volume? So dr r d theta r sin theta d phi. So it will be r square sin theta d theta dr d phi. R square sin theta d theta, r square sin theta d theta dr d phi. So that's it. This is the differential volume. These are the surface areas, and this is your differential length. Okay. So that's it about our coordinate system. In the next lecture, we will see an assignment. We will see a lot of problems, but do not skip the next lecture. A lot of people will skip thinking it as an assignment or there are some problems. If you don't solve the problems, you are not going to understand the concept. So in the problem itself, I will give you a lot of concepts. So next lecture is very important. There we will understand a few concepts as well, and before starting the next lecture, we will see the summary as well. So whatever that we have studied, summary of that we will see. Then we will see how to build a problem solving approach, and then we will solve the assignment. Okay. So coordinate system is completed. After that we will start vector calculus. So now we are going to see an assignment and summary. Okay.